hopefully you'll know what a field application engineer is, but for those that don't, I actually work as a software engineer, one of these fabled characters which Steve mentioned, as part of the sales department at Greenhill Software. So I get involved with the technical teams that we engage with sales with to help them through the difficult problems they may face as they start to get to use our software. So, as Steve again has already mentioned, that there's a lot of ECUs and sensors on vehicles which are essentially communicating, and the way that they communicate and the way that they interact has been evolving as we move towards things like zonal architectures and gateways and so on. And what Greenhill's is all about is the safety and security of those systems, fundamentally. So we have a variety of different tools and operating systems which can be used to, along with the different safety standards and security standards which are appropriate, to maximize to maximize the facility for customers to get their products to market quickly and meet those standards. So that includes things like real-time operating systems, compiler runtimes, hypervisor technology, so that you can integrate different systems from different manufacturers together. And what we see with a software-defined vehicle is when you look at the vehicle, obviously it's hardware, but the software is essentially there to enable different differentialization and features, even post-sale. So at point of sale, you've got your revenue stream, but you want to continue that revenue stream through different market models throughout the life of the vehicle. And so part of this is being enabled by software, and specifically things like feature enablement or new usage modules like robo-taxis and so on are ways that manufacturers are looking to maximize their revenue over the life of the vehicle. But this also impacts on the software developers in terms of things like the development processes that are used. As time pressures to get new features into vehicles quicker affect, we're looking at things like, our customers are doing things like continual integration and continual development. So effectively, as you check in your changes, they might go into your simulation systems, into your test systems automatically, so that a lot more of the process that was traditionally manual is now being automated. And this again feeds back into the tool vendors because we need to integrate into those CI/CD systems and so on. And ultimately, as the vehicle progresses, we need over-the-air capabilities. So as I say, Greenhill specializes, we have a variety of RTOS. Integrity is one of our key RTOSs at the high end of the market, so where you need to ensure safety and security via separation. So I'll mention a lot of people, when you mention security in software, think about encryption, which is obviously useful for data in transit, data at rest, in terms of securing your data. But when you're working on that data, it's not encrypted. So in order to keep it safe, you need to keep it separate from other things which may be attacking or may be trying to compromise your data or change your data. And so integrity provides essentially software compartments in which different applications can run, and with a very high level of confidence and backed up by things like formal method proofs, we can ensure that the different compartments are kept separate, and only where there's a particular channel between them will they interact. So, and again, that's not necessary obviously for all applications. Some are much simpler, and so we have a different operating systems for things like microcontrollers, which have got fewer hardware capabilities, or even for bare target applications, or other solutions like AutoSAR and so on. We have different solutions, slightly different products to help our customers. We also have another business unit which we call Integrity Security Services, and this is dealing with mostly the life cycle management of the product. So when you manufacture a product, it's important for a number of our customers to do metering so that you can ensure that every product, when you're outsourcing product manufacture, you know how many products are being developed to avoid a grey market. And then beyond that, you need to inject into each product an identity, so effectively that would be a cryptographic, some key material, such that the device is unique and then you can monitor that that device through its entire life cycle. You know, from an inventory perspective, this device, which versions of software has it got in it, where is it being used? Is it part of a different system? If for that whole system, then what are the different components which make that up, and what combination of software is on there? So that whole life cycle, and then at the end, you know, of its life, ensuring that it's no longer usable, can also be an important factor for some of our customers as well. And as part of that, you'll have things like device updates, so firmware updates through the life cycle, and also you may also be collecting sort of device-specific log information, depending on the application. Another key part of the ISS business, Integrity Security Services business, is we have our own cryptographic toolkits as well, which customers can use as part of libraries in their products, again, ensuring interoperability and reducing time to market. And finally, we have a multi-development toolset, which is compilers, debuggers, and trace and timing technology, so we can effectively visualize exactly what's happening on a system, as well as, you know, just from single stepping through code to monitoring an entire system and complex timing logs and visualizing them, so we can understand better how the system's working. And this is really key to getting the product to work correctly, is understanding actually what it's doing.